very nice to be here. Thank you very much for the invitation. I'm going to talk this morning about these ideas about how we make software architecture, it's a good way to put it, more accessible to real people. My name is Eoin Woods. I don't know if I know any of you. If I do, please say hello afterwards. I'm the CTO for a company called Endava. We develop a lot of software for other people. I've been there for about 6 years, and we're now a fairly large company. We're in quite a few different countries with an awful lot of people in Romania, as many of you may know. Before that, I spent about 10 years building software products, about 10 years building software for banks. And I've always been a software engineer. I haven't converted in from something else. That's what I did at college. And I've always tried to be involved in community. I think community is really important. That's how we grow the industry. That's how we learn from each other. It's how we get better. I think one of the reasons we're so much better at software today than we were 20 years ago when I was starting, 25 years ago when I was starting, is because we've built communities and we've shared our experience. So let's just give it a little bit of context. Why is software architecture changing? Or what do I think software architecture is changing? Why now? Well, we're in this age called digital. Has anyone here not had a digital transformation? I know your hearts sink when I say those words, because everyone's got a damn digital transformation. But actually, we are, and especially since the pandemic, we're a lot more living our lives through digital kind of mediums. In other words, we're online a lot. And the thing from a software engineer's perspective, I think characterizes the digital age is we are now building things that I term intelligent connected platforms. People give them all kinds of names, but that's what I call them. And a few representative examples of the most famous ones. Google Maps. I think that was one of the very first intelligent connected platforms. It's intelligent because it knows about you to a slightly scary level. It's got prediction baked into it. It adapts its behavior to what it thinks you're trying to do. And it's highly connected. It's connected via mobile devices and traffic systems and ad systems and lots of other systems. By itself, it would be a lot less useful than the way it is, which is connected to millions of other computers, including the tiny computers we carry around. Walmart's Intelligent Retail Lab, that's an environment where Walmart experiment with digital technologies. And again, highly intelligent, highly connected. And it's something that Walmart are building as a platform so people can build on top of. So it's an environment that collects the data. It knows what's going on in the stores. It knows what's going on with deliveries. It knows how many people are entering the stores. And on top of that, you can build useful stuff. Salesforce, maybe the original connected platform. A platform built to be delivered from the cloud natively, probably the first one to do it. That was from almost the beginning. The Force.com platform, if you remember, now called Lightning, was built to allow other people to build on top of what they already had. It was a platform thing. We're going to provide some applications, but also we're going to provide some useful stuff, which you can then use to build your own brilliant applications. The Amazon drones, they're highly intelligent. They bring themselves to drop off packages and bring returns back. They're highly connected. They're not a platform in the sense that you or I can build on top of them, but I'm pretty sure within Amazon, there is a platform that people are building drone applications on top of. And then Cushion. Cushion is an example of a fintech application, which is also, I think, a platform. It's highly connected because it connects to other banks. It's aimed not exclusively, but they started in the US market. One of the really interesting things it does, it's a bit like Google Maps in the sense it knows a lot about you. It keeps an eye on what's going on in your bank accounts. And when it thinks you've been overcharged by your bank, because it's connected to the bank systems as well, it picks up their charging models on a regular basis. It compares the two and goes, you've been overcharged for bank charges. And it automatically connects to the bank on your behalf to try and claim a refund. This apparently is a big thing in the States because they pay a lot more on individual transaction fees for banking than most of us do in Europe. So, I mean, it's intelligent. It knows a lot about you. It's connected to both you and the banks. And within Cushion, again, it's a platform. And I think you can extend Cushion with apps on top of it as well. So it's a platform application. So these are the kind of things we're trying to build. And, when we came at software architecture years ago, I've got grey hair now, so I started quite a long time ago. Software architecture tended to be something done by a central small group, sort of high priests and priestesses of architecture. And there were more women architects actually back then than you might think from the number of software engineers, but that's a historical aside, but there were definitely priestesses too. And it was all about organizing the big pieces of the system. I mean, systems were built out of monolithic pieces then, and actually identifying the right pieces, putting the right functions in the right places was absolutely critical to building a good system. But the connections between them were pretty static. You sort of had 2 or 3 big servers, and they connected together in a very static organization. They didn't go discovering each other dynamically. It wasn't possible, really. They were connected very statically. There was a single set of connections to a database that was very well thought out. There was no dynamism about that. And a lot of architecture was done before implementation happened. Now, architects would always point out they worked iteratively. They changed when they needed to. But there was a bit of an assumption that before you started, you sort of knew what the architecture was. And it was probably going to stay reasonably stable during development and early delivery, unless you'd really made. And so what we did was we built structures. We didn't define structures. We also built, skeletons. We obsessed about qualities, performance, scalability, security, and so on. We did a lot to work out stakeholders. Software architects were one of the first people, along with business analysts, to realize that lots of people care about a system, and they all want different things, and they often conflict. So we've got to work with them to work that out. And lastly, we did a lot of technology choice work. So teams, all need to use exactly the same technology. This was way before microservices. Remember, all monoliths. So, we made a lot of technology choices that were pretty well set in stone. So that was the historical context. So what's changed? Why not just do it today? Well, let's look. First, along came Agile. Agile was triggered by the software industry's inability to get stuff to production quickly. And it said, we should be working in an iterative manner. We should welcome change. It's all about people doing the right things. It's not about having rigid processes that people follow mindlessly. It's all about adapting to change and having a partnership with our client rather than trying to write everything down in a fixed price contract. And what that allowed application teams to do was to start having much smaller pieces of function in their monoliths, but much smaller things ready to go to production much more often. But that often created a problem for us in that the infrastructure environment, it took 6 months to get anything changed. So if you needed something changed, you couldn't put your application software into production anyway. So one of the responses to that was cloud and infrastructure as code. The infrastructure people went, well, okay, we're sort of inspired by what you're doing there. If we put all of our infrastructure being software defined, actually, one, we could deliver it across the internet. That would be quite cool. And secondly, we could build our infrastructure very dynamically. In fact, we could give you the ability to build the infrastructure. So this was kind of a case of, the application team saying, there you go, we've solved our problem. And the infrastructure team's going, we'll raise you your problem. We've solved our problem as well. And the problem the application teams then found was they didn't really move as fast as they thought they did. And in particular, releasing one of their monoliths was pretty risky. And you had to get a lot of teams typically lined up to get all their work into the right state to ship it. So one of the insights that a number of people came up with at the time was, we've been trying service-based computing for quite a long time, and the essentials of it are pretty effective. But a lot of our services are very big. If we had much smaller services, we could have less people working on one service. And if we defined the network interfaces properly and kept them pretty stable, or at least compatible, we could allow different teams to release at different times. So suddenly you got this sort of avalanche of change happening, was that individual teams could ship their stuff within certain constraints almost any time they wanted to. Of course, the people who hadn't been part of this party, really, particularly the microservices bit, were the operations group. So from their perspective, they got this avalanche of change, which they knew almost nothing about, and somehow were expected to support and possibly even improve. And that wasn't very fair, and understandably, they didn't react very well to start with. So that's where the DevOps community, about 7 or 8 years ago, I guess, and actually its roots were older. I was working with ops teams to integrate them into dev before we called it DevOps. So various people were thinking about it, but got real momentum maybe 4 or 5 years ago. And we said, well, why don't we just work as a cross-functional team? Then you know what was going on. You'd be able to tell us where we're going wrong. That's dev to infrastructure. You can have your input into the application software, and we can have our input into how you design the infrastructure. And it's been a big success. The result of this, though, is that architecture, when you think of what we used to call architecture today is much more fluid. When you think that a lot of the constraints have been taken away, we've got lots of small pieces and we can change the infrastructure with a line of code. The architecture is much more fluid. We take advantage of that to ship software earlier, but the earlier we ship things, the less we know. So we tend to have to evolve things much more. And the other reason we have to evolve things much more is we ship things early when they're only partly done, knowing that we'll have to finish them. And that's deliberate. I mean, that's absolutely the right thing to do, but it does mean that the architecture has to be able to react to change more than it used to have. And I'm not saying the old ones couldn't. I used to pride myself on flexible architectures. But I look at the architecture we're doing today, it is definitely more fluid and flexible. It can evolve faster than what we were doing 20 years ago. And why is this really a problem? Well, if we've got Adriana the Architect, who's looking after a small group of teams who are building a small digital platform, it will all start off fine. I absolutely guarantee it. Is that, oh, my graphics have gone mad, not to worry. The teams will start shipping software to production, and that will all be fine. But, you know, teams are, one, in my experience, not short of opinions, and two, they tend not to be short of questions either, especially when they're building something reasonably complicated. And these three teams are having to coordinate their work to make sure that we build a coherent platform that's secure, scalable, performant, all those things. The problem we get today is that all of these teams are working independently, and so they all have their own ideas and their own problems at different times. And if you have a single architect, or even a little group of them, they get a huge backlog of questions to answer, problems to resolve, new decisions to make, and they just get a bit overwhelmed. And one of two things happens. Either what shown on the slide happens, which is the teams keep asking questions and pause until they get answers, in which case velocity crashes, or the teams go, I can't let the velocity reduce, I'm just going to continue. And so you get a huge amount of divergence, and so you get problems in the system. So those are the two problems. This doesn't mean Adriana's a bad architect. In fact, she's probably brilliant, the fact that she's got as far as she has, but it does suggest that if she changed her ways of working a bit, she might be able to help the teams more. We'll come back to Adriana later and see where she got to. I would postulate that what we used to call software architecture, the traditional approach, is of less value. It's not to be thrown out. You know, we don't want to throw the baby out with the bathwater, as we say in English, but it is of less value, and that's because autonomous teams create a lot of independent activity. Independent activity creates a lot of parallel decision making. Constant decision making, especially in parallel, causes architects to be overloaded, or that just causes them to context switch the whole time. And you know what context switching is like, it just kills your productivity. This blocks progress if you try and use the sort of traditional approach. The flip side of this is that our system is going to be shipped much earlier with much less complete, the MVP approach. So the system's going to keep evolving. And because we ship it into production early, we're going to learn a lot more earlier, and we're probably going to change what the system does and how it works and what its trade-offs are and all those things. So we've got a lot less certainty early in the life cycle. And I think that's by design. But the side effect is the less you decide early, the less value a really rigorous, well thought out, highly structured, very validated architecture is, because it's probably just going to change. It's going to change a lot. And so we need to embrace that rather than being threatened by it or by just tossing software architecture to the side and saying, not to worry, let's move on. The obvious question, throwing stole my thunder slightly, you must have read my mind, Florian, is architecture still needed? Well, you know, you won't be surprised to hear from me. My answer is yes. But that's not just an emotional reaction, although if I'm honest, there's a little bit of that. But no, it is based on logic. The reason is there's three main reasons, I think. I mentioned them in the introduction. We've still got stakeholders, and stakeholders are often difficult people. Or they don't mean to be difficult, but stakeholders, for example, the compliance group and the operations group and the end users and the support people and the acquirers and all these people paying for it, that is, all these people want different things from the system. And even when you look at users, some users want really fast screens to do really simple things. Some people want really powerful screens, which they don't really care so much about the performance. They do really complicated things. They all want different things. And the trouble is what they want conflicts. There are definite conflicts between them. And all that needs to be untangled. And it's really hard for a single team tasked with a single area of the system to untangle that at system level. Second thing is quality attributes. We used to call them non-functional requirements. The architecture jargon for it is quality attributes. They're the same thing. Performance, security, maintainability, flexibility, reliability and resilience, all those things. Achieving those is almost never the job of one team. It's always a cross-team problem. So somehow, whether you have an architect to do it or not is completely irrelevant in my head. You've got to have a way of solving the security problem across all the teams. The teams cannot do their own independent security. It's got to be joined up. Um, I mean, other things like, even logging. I mean, a really simple example. If you've ever supported a system where different teams did logging different ways, you'll know the immense pain and how difficult it is to support it. So there are things that need to be lined up. And there are also lots of trade-offs. The trade-offs that we see in a system are where we would like it to be infinitely fast, delivered with zero time, to be totally secure and be really easy to use. The problem is we can't do that. And so if we want it to be really easy to use, we might need to change the way we do security. If we want it to be really, really fast, we might not be able to make it as flexible to change. If we want it to be delivered in, very, very, very quickly, we might not be able to make it performance secure and reliable. So, these things are trade-offs. And again, there are trade-offs within the teams. I'm not pretending the teams don't do any of this. They do, but in their local context. A system context, there are complex trade-offs to make. All of these become what I call, well, not just me, people call cross-cutting concerns, meaning things that go right. That's why I keep making this sign subconsciously. They're concerns that have to be addressed across the whole system, not in one part of it. They may be addressed in one part of it as well, but that has to be congruent, has to be aligned with the overall systems approach to achieving that. The difference, though, to the good old days, or the old days, they weren't that good, is that architecture is no longer something that's mainly completed up front and refined as we go. It has become a new approach, which is a minimal sort of set of structures and decisions made up front, and then it becomes a flow of decisions as we go through the process of building the system. So this approach is called continuous software architecture, and it's been used by a number of people in a number of places. Some academics work on it, particularly Jan Bosch's group in the Netherlands and the Nordics. My colleagues, Murat and Pierre, have been talking about this for a while. People talk about agile architecture. Eljo Poort at CGI in the Netherlands, again, funnily enough, he's got an approach called risk and cost-driven architecture. A lot of these ideas are closely related. They, of course, vary slightly. There's a team at Michelin in France. I'll show you their website at the end. They also talk about continuous architecture. But there are a number of philosophical things that absolutely link these different ideas up. So what does architecture look like in this new world? Well, the first thing is, I firmly believe architecture is a skill, not just a role. And I mean, my group head of architecture, our group head of architecture at Endava, Christina Cooper-Bland, she's always saying this. She wants everyone to have architecture skills, not just architects. Architects are people who've chosen to specialize in this area, but we need architecture skills right through the team. Architecture has become, because of this constant evolution, it has had to become a stream of decisions, not something that happens mainly at the start. And rather than defining the structure of the system, the thing that will not change, actually it's become much more about saying, here is the type of structure that we need to achieve and why. And to achieve that structure, there's certain architectural style or styles we're going to use. For example, we are a message-driven, event-driven system with a blackboard in the middle, for example. That's the style we're using. So everyone thinks, right, I kind of know what one of those looks like, and we don't just start from scratch. There are specific patterns, such as the event handling is going to use this pattern, and we all are going to use the same pattern for these very good reasons. For example, perhaps recovery. We all process messages in the same way, so we have a coherent approach to recovery. And we will state what's important to us and what is not important to us. We call that principles. So principles are things like, we recognize there is a trade-off between security and usability. While usability is important, ultimately security cannot be compromised. That kind of principle. Principles also things like, if we're going to you design a message protocol, we would always like an industry protocol. If we can't have an industry protocol, we'd like something from the organization. And if we really can't have something that's shared, then we'll use a point-to-point. So the principle is reflecting reality. We can't always do what we want, but it's being very clear as to, here's the order of things that we all agree here's how we're going to do it. And those are the three possibilities for designing a message schema. We'll always use an industry one first. If we can't do that, then we'll always use an organizational one. If we really can't do that, we will create a point-to-point one. I mean, that's actually a very useful principle because it makes our preferences clear. I do have a talk on principles. If you're interested, I'm sure it's on YouTube somewhere. Architecture now is about delegating and sharing. Honestly, I have always observed that. And the architects I learned from and I really admired when I was a young engineer, they always delegated. That's how I became an architect. They delegated things to me. It was great. They always shared. They shared their knowledge, they shared their thinking, they shared their philosophy of how they went about things. However, some architects over the years have had a bit of a reputation for keeping things to themselves, wanting to own all the decisions, not being prepared to share, not being prepared to delegate. That's got to change. Because with these distributed teams all over the place, especially working virtually, all on their own bits of software, you've got to delegate and share. We do little architecture work little and often, meaning all the time through it. And as we learn more, we adapt what we're doing. And finally, we aim for architecture to be something that everybody owns. It's not owned by the architects. It's not them over there. It's not something on the wall that I've never understood, never will, and I'm going to ignore. It's something that we all think we own. Because if the architecture is not living, if it's not embodied and lived by the people building the system, it's pretty useless. Murat Erdem and Pierre Pura are colleagues of mine in the sense that they're professional friends I have. Murat works for Deutsche Bank now, and before that he's worked for a range of consulting firms. They met in consulting, and Pierre has just retired after a very long and distinguished career at Travelers, the huge American insurance company, where he went from junior software architect to chief architect. They, a few years ago, wrote a book called Continuous Architecture. That's I knew Murat slightly beforehand, but that's how I really started working with them, because I picked it up and went, yes, those are the kind of things that I was thinking about. And they've identified 6 principles, which I think are pretty good. One is that think about building products. We need something that we can evolve for the long term. We don't want to organize ourselves as a sequence of unrelated projects where, we do a project and then everyone goes and works on something else. Think about building a product for the long term. People get to own it, they get accountability for it, and they evolve it for the long term. So think about products. Hardly radical, but they did write this 5 years ago, I think, when actually there weren't many people thinking about that. Second thing is, don't forget your quality attributes. In fact, make them your architecture focus. Other people will look after the functionals most of the time. Occasionally, Chris Cooper-Bland actually pointed out to me, she comes from payments. She says, well, actually, in payments, there's some really tough functional requirements that really require architectural input. I go, absolutely. There are some, but there's an awful lot of functional requirements which people can just get on with. I mean, they probably can be delegated to an individual team and they'll do a fantastic job, probably better than you will. The thing that, as we've said, needs architectural attention is quality attributes, because the individual teams can't solve those. Delay your design decisions until absolutely necessary. This is how we're starting to move away from good old classical practice where we try and make a lot of those up front. We know a lot more once we've delivered 3 iterations than we did before we delivered anything. We know a vast amount more after a year of production operation than we did when we were still in development. So this is not about not making design decisions. It's about deferring design decisions until absolutely necessary, obviously inspired by agile thinking. Of course, the corollary to this is don't leave it too late. And they talk about this in their book. It's important to know when a decision is absolutely needed, because you've got to be able to make a good decision before that point, not get to that point and just make the first decision that comes into your head because you haven't spent the time preparing. So that's not to say we don't prepare and we don't think up front. We do, but we don't finalize decisions until we need to. Architect for change. By this, they're saying whether or not you use microservices. I mean, microservices in themselves are not a magical solution. What they mean is when you're building your system in this age of digital delivery, continuous change, you're going to have to change your architecture. So just think about it early. And as they say, it's not necessarily about building microservices, but having a lot of small things that are connected via well-defined interfaces makes something much easier. Simon Brown talks about this a lot. As he says, if you can't structure a monolith well, what makes you think you're going to have a great success with microservices? And he's right. With a monolith, you can still absolutely structure it internally as a set of small, well-encapsulated, coherent pieces that communicate through very disciplined interfaces. That's a lot easier to change than the big ball of mud. I'm sure many of you have had exactly that experience. Principle 5, don't forget build, test, deploy, and operate. Why? Because if we're not really good at those, we won't be able to deliver reliably to production and keep it reliable in operation quickly. Suddenly, we'll do lots and lots of great sort of development work, and our build's all ad hoc and we don't test properly, so we can't release. So what they're pointing at is don't forget the fact that your architecture has to directly support building it, testing it, deploying it, and operating it. And if you're forgetting about those things, you're not doing a good job for your team. And finally, remember that Conway's law, I know timeless wisdom, but it keeps coming back. Bear in mind that if you try and develop your system in a way that the organization doesn't support, there's going to be a lot of pain, because communication priorities and direction are going to be very hard to align. So need to kind of it's not telling you what to do. In fact, there's an excellent book, Team Topologies, which is on my final slide, which is great to talk about that. This book doesn't talk about what your team shape should be. It just points out your team shape has an effect. So just because you're an architect, I must admit, I'm not much of an organization and process person. You do need to make sure that the organization's got the right structure, and maybe be feeding back to the senior people managers, the line managers, going, I'm not sure you've got the right structure. For the kind of system we're building, I think the communication needs to flow like this. And then, you leave it to them to figure out how to achieve that. But always bear this in mind, that with the wrong organization, it doesn't matter how good the people in the architecture are, it's just going to be a bit painful. So the way this looks is that if you want to kind of visualize it, I'm very much a visual learner. The way it used to work was we have stakeholder concerns. So lots of stakeholders, we trade them off, we come to the best sort of local optima, if you like, for their needs. And we do a lot of sort of what people like to call blueprinting. I think that's a bit misleading, because a mechanical engineering blueprint is actually like code. But anyway, people like to call them blueprints. So we do sort of models. This is how the system is going to be. And then we go into a delivery cycle where, we do some more detailed design, we construct it, we test it, we deliver it, and we analyze how well we did. In each iteration, we produce something useful, and we do incremental delivery, and we hope we can put it in operation. Historically, I think you'll agree, we often weren't very good at that. We used to have all those little boxes, but they used to end up in a bit of a stack waiting to go to production, often because we hadn't worked very well with our ops colleagues. But let's kind of exclude that from this particular discussion. So this is what kind of good practice in the old world looked like. What changes? Well, the difference is that we have a single cycle, including the architecture. Yes, the early cycles would have a lot more architecture than construct, or a lot more architecture than deliver. The size of the wedges changes at different points. Some iterations you do a lot of architecture, some iterations not so much. Then later on you do a lot of architecture again. But the important thing is it's an integrated cycle. And as you're doing architecture, you're doing two things. You're making decisions, hopefully really good decisions, which will last the test of time, but you're certainly making decisions that you record. They're rational, they're well argued, and they're well explained with good context, so people know why you made the decision. So when they come to it later, they know whether anything's changed. Maybe the decision's still valid, maybe it isn't. If you don't write it down, it's hard to know. The other thing is we build architectural knowledge. We know where the trade-offs are, we know how the system works, we know what the critical requirements are, we know which qualities are really hard to meet, which qualities we don't need to worry about. All that knowledge which is in the architect's head historically, we try and record in some kind of architecture knowledge base. So we call this agile development with continuous architecture. And we still get incremental delivery out the back. However, hopefully, different talk, but hopefully we've been working with our ops colleagues, integrating them into the cycle, particularly in construct, test, deliver, and design. In fact, probably all of it. And so we're able to put these into production. I have to acknowledge that this is very much inspired by Elcho Port's work on risk and cost-driven architecture, or RCDA, as he calls it. There isn't a definitive book on RCDA. Maybe someday somebody will write one, but there is some information about RCDA out there on the web if you'd like to delve a bit more. CGI also run courses, but just to acknowledge that we didn't do thinking, and I don't do my thinking in a vacuum. Other people have had really important thoughts along the way. And Elcho hasn't had a thought. He's delivered a complete approach for incremental architecture driven by risk and cost. So what we'll end up with is that whereas we used to have fairly top-down design, fairly prescriptive, we're going to end up with this much more evolving shared design, where we define styles and patterns. We define sets of principles, the things we believe to be important and less important, to guide our decisions, and a stack of decisions. And early on, the stack of decisions won't be that big, but once we've been through 5, 6, 10 cycles, we should have a lot more decisions in our stack, and they should be captured somewhere. I'm a big fan of wikis, as anyone who will work with me will know. I'm a real pain about people putting stuff on Confluence, but I do think wikis are really great because there's no barrier to consuming them. They're just HTML. And they're really easy to put information into and modify and link across, give people context. But however you do it, keep them in Excel, keep them in Word, keep them in markup, use architectural ADRs, check to your code line. I really don't mind. But the important thing is you capture your decisions. And why? Because as we evolve, we need to go back and revisit decisions. And if we're not sure who made a decision, or quite what the decision was, or even more importantly, why we made the decision, that's really tough. So where do we end up with if we do that? Well, styles and patterns will give us common solutions to our repeating problems. So hopefully we'll get some commonality across our system. Principles will give us guidance to achieve aligned design decisions. We'll all make decisions in the same context, bearing in mind the same philosophy and constraints. And we'll have a set of decisions, explicit decisions. We'll know what decisions we've made. We might even put entries in for decisions we decided not to make, or we just let the teams decide for themselves. We might actually say this is a non-decision. We decided it wasn't important, but here's our rationale. It helps us understand what we did, when, and why. And what we're hoping to achieve is an evolving shared design, rather than a design that's seen as theirs or hers or on the wall. It's something we all kind of live. How we visualize it, how we model it, and those again who know me will know I'm a big fan of modeling, but how we visualize it, how we model it, how we represent it, to me, these days, those are kind of secondary. I would like you to have a representation of your architecture, because actually, I think it helps everyone, even the people who are writing it down. It actually does help them to write down how it works. But the important thing is that everyone's got a shared understanding of what the architectural design is, rather than the particular form you capture it in. And another brief shout out there for Simon Brown's Structurizer tool and approach, where he has designed an approach to representing your architecture using Java classes, which I think is really clever. In fact, I was going to go and do a PhD on that and realized that Simon had done way more than I could ever do. So I dropped that and did something totally different. I really admire Structurizer. It's a really clever tool. If you're thinking about, I'm struggling a bit with how to represent architecture, what options do I have? At least add Structurizer to your long list and go and take a look at it. The thing to remember when we create artifacts, because there's an awful lot of artifacts created that aren't very valuable. And I even see this in Agile teams. It always makes me smile quietly. Obviously, I try not to smile to the team, but Agile came about because it was a reaction from the original kind of Agilists to looking at waterfall development, following structured methods that, in their view, created a whole lot of artifacts that were pretty useless. They created a lot of effort to create them, and yet they provided no value, and no one ever read them. It grieves me to say it, as I was back then, probably something of a proponent of structured methods. They were right. We created a lot of artifacts because we thought it was good to have them. The number of times we used them, pretty low. So, it was absolutely the right thing to do. However, today there are two problems. One, people are still creating artifacts that aren't very valuable, and they're still taking the time. And two, people don't create any artifacts at all. We do need artifacts. Artifacts are our kind of shared cultural reference points for how our system works and where we've come from. But when creating them, make sure they're minimal, small as possible. Why? One, because it makes them easy to consume, and two, because it makes them easy to change. Make them usable. Think about, what are we going to use this for? Who's going to use it? In that context, how would they want to consume it? And if that takes you a bit more time when you're creating it, well, that's just the way it is. If you're going to get people to use it, you need to put the effort in to make it valuable. Is it significant? In other words, does anyone care? There are artifacts created all the time, even in Agile teams, that honestly no one really cares about. For some reason, somebody decided it was a good thing, but there's no actual kind of reason for it to be there. Or my particular bugbear is where people decide to create an artifact to do with the code structure. It would just be quicker to get it out of the code. Things like someone creates a long list of configuration parameters on the wiki with descriptions beside them, which are not, they haven't even got great descriptions. And actually, there's a source file with all the configuration parameters with a comment above them telling you what they do. it would just be better to put a link on the wiki to your GitHub to say it's in this file. In fact, back in the bad old days when I was starting off in my career building Unix system software, there was quite a lot of that. We didn't have wikis, but there was quite a lot of that. Was that there were certain parts of the code line you went to find the documentation. I mean, there were no documentation files. There were certain key source files were commented in a way to try and record information and you knew it was significant because somebody had taken the time to put the to revamp this source file to make it usable by someone, and it was really minimal because it was in the code. The other thing is, can you find them? Today with enterprise search, maybe indexed is over stating the point. They need to be locatable, if that's an English word. However, we have my colleague Nat Price came up with the lovely acronym music, so I really didn't want to drop the I, so I've left it as index. But you know what I mean. You can find them. This is a problem even for teams with Confluence. They produce a huge heap of documents, no tagging, no real structure, not terribly obvious headings, no hierarchy, and everyone, by the time you're at 200, no one can find anything. So there's lots of wisdom there, and people might have created minimal, usable, significant artifacts, but you can't find them. And finally, make sure that they're checked. There's two parts of checking. One, make sure they're correct. The second thing is make sure they stay correct. Somebody doesn't, I mean, this is overhead, but it's the price we pay for having knowledge. You need to go back and check them occasionally. I'm not suggesting every Monday morning, but occasionally, maybe after every, major, evolution cycle, you go back to things and just skim over them and go, what's changed? Oh, actually, that's quite misleading now. And at the very least, mark it as misleading. Maybe I haven't got time to change it, but mark it as misleading. And in summary, always make sure you've got an audience and a purpose. If you're always thinking about an audience and your document's got a definite purpose, you will tend to create usable, significant index check documentation. Those are if you're going to take two things away about creating things, make sure they've got a purpose and make sure you know who's going to use them and for what. So what are the activities that we find in continuous architecture type projects? Notice I don't say continuous architects doing. I say I'm pretty relaxed over whether somebody's called architect or not. There are many large companies who are very, very successful, and I greatly admire, Google being one of them, who don't really have people called architect. They expect architecture skills in all of their senior engineers. So the important thing is the activities get done. And the first one is provide leadership, that is technical leadership. Teams need technical leadership, even if they don't always know it. The more junior the team, the less normally they realize they need technical leadership. You may have had that experience. So provide technical leadership so people know where to go for coaching, mentoring, direction. Focus on quality attributes because nobody else will be. Whoever's taking architectural type responsibilities, the individual teams will not be focused on quality attributes at system level. I can guarantee it. So focus on quality attributes. Drive the architectural decisions. Quite a common anti-pattern I've seen over the years is that a lot of software people are not very extrovert. I'm certainly not. I'm only too comfortable being an introvert. Thank you very much. So they're relatively, I wouldn't call them introverts, but not very extrovert. They don't necessarily like conflict. And sometimes they can get quite uncomfortable if they feel that if they don't have all the facts in their head to support their argument. The result of this can be a sort of passive or almost implicit agreement not to make a decision. I'm not quite sure I'm right, and I don't really want to make a fuss, and I particularly don't want to have to explain this to 50 people in a big room, but I'm not sure you're right either. And the other person thinking, I'm not sure I'm right, but I don't think you're right either. And they go, I don't think we want a conflict, do we? We'll just sort of pretend that we agreed. And they just sort of get on. And the decision's never made. One of the responsibilities of the senior people, this is part of the leadership really, is make sure architectural decisions are made. Walk to the whiteboard with the pen saying, right, we need a decision on this. What are the options? What are the trade-offs? Who knows about this? What don't we know? How are we going to fill that missing information? Bingo, we have a decision. Does everyone agree? I mean, it's that kind of leadership. I know it's not easy, particularly for those of us who come from, pure software development backgrounds or pure electronic engineering or something like that. But that is what the modern kind of digital architect, if you like that phrase, needs to be doing. Because remember, we need the decisions owned by the team. It's no point us making decisions in a corner anymore. We also need to manage technical debt. All this evolution can take its toll. We can really end up with significant problems with technical debt. I mean, we work with clients all the time where, honestly, by the time we've got to got to the project, we're really making kill or remediate decisions. It's an open question as to whether this system can be saved. I did this. I mean, I've done this a couple of times in my career before in Endava. I've been hired specifically for that. It's kind of, oh, we genuinely don't know whether to just kill this project, write off the investment, which is big, or whether it can be saved. Luckily, at least in the two major cases that I took over, we saved it both times, which was really good. But to avoid getting into that situation, everyone's got to get better at managing technical debt. I think we've all known about it as a background thing, or technical debt, for quite a long time. But honestly, you look at the number of systems that my colleague Radu Marinescu leads the analysis of it in Endava, the technical debt in those systems. A lot of us are being pretty casual about building up technical debt. And I don't think it's that we don't care. I don't think it's that we don't understand. I don't think it is a fact of us not believing technical debt is important. It's the fact that we don't actively manage it, so it creeps up on us. And by the time we look around, we start thinking about it, it becomes a bit overwhelming. We just think, that's just too hard, I'll look at it next week. And next week never comes. So managing technical debt proactively from the beginning, another important technical leadership thing. Finally, implement feedback loops. If you're doing continuous delivery, I mean, I'm sure you're all doing perfect continuous delivery from commit, or from idea to commit to production and operation, and there's never a problem. Yeah, well, you might have one of the real projects where actually the continuous delivery cycle is harder to make smooth than people thought, and it takes quite a lot of time and effort. But one of the things one of the great things this is enabling is learning from operation. Not learning by product manager guesswork, not learning by surveys run by a market research firm, not learning by focus groups on, of developers, or whatever, way that we used to do user analysis. We've got it in operation. We shove it out there. We see what people use and don't use. That's a kind of product feedback loop, and we need exactly the same feedback loop for technology. When it's in operation, we should be learning. I mean, we are learning, whether we like it or not, a lot about how good or bad the architecture is. So we need to implement a technical feedback loop explicitly so that we are using those learnings. Some of it's technical. The fact that, for example, we need to have good monitoring and tracing and logging in operation, and we need to have dashboards, and we need to, produce, we need to have alerts and trends, and we need to put, automated, this idea of a fitness function, which Pakwa and I won't remember their names now, Neil Ford and Rebecca Parsons thought up in their Evolving Software Architectures book. We put fitness functions into our environment effectively as watchdogs, as alarms for certain quality properties going bad. All of this stuff helps us to get a feedback loop, but however we do it, I mean, we can do it as simply as, taking the time every morning to check the production dashboard, actually, but however we do it, we must build in feedback loops. Otherwise, we're going to miss out on a lot of the benefit of having an architecture that we can A, deliver incrementally, and B, change all the time, because we won't be changing things in an informed way. Some specific useful practices, these kind of, I have mentioned some of these before, but doing architecture work in every sprint. There's nearly always something to do, so reserve time in every sprint. The other thing in every sprint, as an aside, is to reserve time for technical debt repayment. But in this context, I'm talking about architecture, so make sure there's time for architecture work in every sprint. Focus on decisions, principles, styles, and patterns. Those are the things to be thinking about. Do we understand our architectural style? Have we got good codified patterns for all of our common problems? Do we know what principles that we want to follow when making decisions? Do we know what our architectural decisions are? Deliver decisions as they're needed. Don't either try and make a load up front or get surprised because we suddenly need a decision and, whoops, I haven't got any context, I'm not quite sure, so we'll do the same thing we did last time. It works both ways. Yes, defer your decisions, but you're going to need to, at some point, know when they're needed and make sure you've got enough time beforehand to make a good decision. Form an inclusive architecture group. Architecture, as I think I've said repeatedly, we want it to be a shared commons. We want everyone to buy into it. So not everybody can sit in a room and come up with an architecture. That's too many people. But you can include, you can consult widely, but also form an architecture group across the team and make sure that all the important groups are represented. So everyone knows who can have an architectural influence in their environment or their specialization or their team, whatever it is. Write as many practical tests as you can to validate architecture work. Very often these are non-functional tests, but also, for example, can you build tests into your pipeline that check your code structure? Can you put tests into your pipeline that check for architectural structure rules? Can you put tests into your pipeline to check for things like, well, classically, even test coverage? Can you test the overall technical health of your system, right, which is kind of what we mean by the architecture? So fitness functions are one idea about that. Do go and have a read of those if you haven't already. Also, some, as they point out in the book, some fitness functions can't be automated. Have you got a spreadsheet that's tracking trends in operation, which you can use as your own little model to explore what-if scenarios? So, that's a pretty practical test as to what will happen if we had twice the transaction volume for 3 days. Oh, nothing, good. Or, oh my goodness, it would be a disaster. And keep the architecture as close to the code as possible. The worst thing is architecture on PowerPoint, code in GitHub, no connection between them. At the very least, all the concepts in the architectural artifacts, you should be able to find them with grep. Nothing more sophisticated than grep in the code. If you can't, that's a sign the two are totally disconnected. But beyond that, there's lots of tools out there. Visualize your code structure. Does it look like what you'd expect given the styles and patterns that we were expecting? You can probably build yourself little tools. There are tools like ArcUnit, which unfortunately I think is now dormant, that try to implement certain kind of checks on code structure. But I mean, I know that's only one part of it, but you've got to satisfy yourself repeatedly that you've got an architecture, you've got an architecture, or you've got architecture artifacts, you've got code, which is true. Well, hopefully they're both true, and the real architecture is the meeting of the two. But keep validating that for yourself. So to conclude, there's two things changing, and this is because of this new digital world we're in. Agile and DevOps are terrific, and they are changing how we work. They are, in my view, radically improving how we go about developing software in this industry. Cloud and containers and other stuff, I mean, those are just representatives because they alliterate nicely because they start with C. But, infrastructure as code, hybrid cloud, beyond containers, things like container orchestration, service meshes, all this great new stuff is changing how we build. In particular, a lot of the old barriers have gone away. The result of these two things happening, kind of colliding together, is that as architects, as historical architects, or as people trying to do architecture work today, there's a lot less upfront architecture. Or rather, if you do a lot of upfront architecture, my hypothesis is, and I think my experience is, it's going to be of less value. Quality attributes, trade-offs, and stakeholders, however, have not gone away. We still have got really demanding and awkward stakeholders who need looked after and need to understand the relationship between their needs. We still need to trade off between technical decisions and stakeholder needs. We still need to meet quality attributes. If anything, these digital platforms, they have much more demanding quality attribute needs than we ever had before. When can Salesforce take their system offline for a couple of hours? That's right, precisely never. When is Salesforce under attack from hostile agents? That's right, 100% of the time. So actually, some of the quality attributes that used to be tricky are now hard. So we've got to, they need real work. We need to move architecture to being a flow of decisions. Why is that? Well, it's because there's lots of parallel work. There's lots of evolution going on. Honestly, decisions all made up front are much less valuable because they don't reflect the changing reality. This means that what architects do every day is changing. I observe this on our projects, even in the 5-6 years I've been in Endava. The work the architects are doing is changing. For example, when I joined 6 years ago, we did a lot more form modeling in UML and many other things than they do today. Today, they're much more sharing concepts and ideas and sharing it relatively in sort of less formal notations, but sharing it with the teams via things like confluences. I just tripped across a team the other day. I was helping with a bit of cloud security, and I was actually really proud of them. It was a .NET project. We were using some combination of kind of C4 and a bit of my stuff and a bit of somebody else's stuff. All great. But actually, when I looked at their wiki, I could within minutes work out what their architecture was. It wasn't some big formal model that had taken them months. They organically built a really good set of wiki pages. And I was really proud of them. And I'm sure many of your teams are starting on that road. Your challenge is find the teams who aren't and don't know what to do about this and get them on the same road. And then finally, the way we train architects, if our architecture training is the old classical books, my first book included to some extent, although of course I still think it has value. But some of the things in that that's why I wrote another book with Murat and Pierre. Some of the older books, some of the how to go about it, possibly need evolved. A lot of the architecture fundamentals about security and performance and so on is probably the same, but we do need to think about how we train architects to work in a different way. We used to, I think, train them to think very rigorously, to work in a small team, to validate their work, to communicate it to others. They've now got to be in the center of the team, being a technical leader. For some architects, that's not a terribly comfortable position. And for people making the transition, we've really got to help them and support them in that. I'm sure they can make the leap, but it's a leap. They need a bridge built with them. You have to hold them by the hand and help them come across into the new world. So what we're really trying to do is we're trying to take Adriana the Architect and move her from the historical purveyor of wisdom, knows everything, knows how the system works, publishes it, everyone reads it, goes, wow, Adriana, you're great at this, and gets on with it, to Adriana's the technical leader at the center of the team. She's helping the team define that. She's probably selecting the style, to be honest, but she's certainly helping the teams work out what styles they need. She's making sure the teams have designed good patterns. She's stepping in and mentoring people, correcting patterns when they've got it wrong. She's pointing out what's missing. She's putting the checklists together for the teams for their quality attributes. She's looking at the system as a whole, and she's putting the overall strategy together for how we're going to be secure. What's the scalability approach? How is this going to be supported? She's making sure that when the teams need to communicate, the teams are communicating. And she's making sure that everybody's thinking about this continuous delivery cycle, rather than, I come across Scrum teams who are, dare I say it, a bit waterfall in their thinking. She's thinking to everybody about change is just going to happen, deal with it. And she's being that leader that shows people how to live that. There are a number of books. George Fairbanks' book is a great one for teams making the leap to architecture. Mike Keeling's book, Mike and George are close friends. You won't be surprised, it's pretty similar. But it's also about how you go from being a developer to a software architect. It's a bit newer than George's, and I think George has provided a lot of the ideas for it as well, because the two of them talk all the time. But Mike's is a much newer book, both though very valuable. Software Systems Architecture is my first book. As you know, it's got, I still think it has a lot of information about working with stakeholders, structuring artifacts, and quality properties, but it is an older book now. Continuous Architecture is the first book I think was written on the continuous approach. And Continuous Architecture in Practice is our brand new book, where continuous architecture is a bit of a model. This is how we think this should work. The new book was written as a reaction to a lot of people saying, this looks lovely, where do I start? And so we've tried to provide a lot of information about, well, actually, in a continuous context, here's how you do performance, here's how you do security, and so on. And finally, I mentioned team topologies. It's Matthew Skelton and Manuel Pais's book. That's actually comes from the DevOps community. And of course, it's also idealized in a model, but it's got a lot of thinking in it about how you could structure teams. And what's really great is they've thought through, from their experience, here's the implications of the different team shapes. And so when you're thinking about Principle 6, we should be intentional about our organization. That's a great resource to kind of fuel your thinking. Couple of quick websites. Continuous Architecture. Slightly confusingly, there are two continuousarchitecture.coms, one with a dash and one without a dash. The one with a dash belongs to the Michelin Group. They're sort of friends of Murat and Pierre, but they have their own slightly different approach to how you do continuous architecture. They have their thing they call the Continuous Architecture Toolbox, which is a set of useful artifacts for how you go about doing architecture continuously. And most of what they produce is freely available. And then there's continuous-architecture.com or continuousarchitecture.info, which is the website for the second book I mentioned, Continuous Architecture in Practice. Thank you very much. I'd be really happy now to take any questions or to just chat about this. I think we've got about 5 minutes left, Kareem.
First of all, congrats. It's been really, really great. I mean, amazing. And very insightful. I mean, yeah, of course, you just triggered a lot of questions for sure. We don't have enough time to tackle them all, but let's try at least two.
Yeah, I think two.
You go first, please.
Just fine. So I was thinking, let's say that I'm an architect that until now I've just worked with the old ways. And right now, after your presentation, I'm very intrigued and I like to change some things in my project. So what would be just a few things that maybe I should take into consideration in the beginning in order to make the transition as smooth as possible? Because let's say I have a complex project and I have a lot of dependencies and stakeholders, so I have to be very careful.
Yeah, absolutely. It's a great question. Honestly, we're still learning how to do that transition. I think, I suppose I made it quite a few years ago, but in a different context. What I found was really important was start thinking about how to defer your decisions. Because for most architects, let's be honest, we think we've got all the answers. Sometimes we've got some of the answers. We rarely have all the answers, but most of us think we have all the answers all the time. So firstly, drink a cup of humility. Think about how you defer your decisions until the point when you know more, but they're not going to be too late. And that actually triggers a whole lot of other thoughts about, oh, so maybe a big model up front's not going to be very useful. What would I do instead of that? So that's one thing. The second thing then is, how do I share my knowledge, and how do I make, and together with that, how do I make the architecture owned by the team so they don't keep pointing at me? If you can start just thinking about steps towards that, it's going to take a year, 18 months to do it. But if you just think about how do you take steps towards those goals, defer your decisions, make the architecture a shared commons, an awful lot of the other bits just slot in because you go, oh, well, actually, if I'm going to share it, maybe I should think about an architecture team, maybe I should delegate quite a bit, and maybe I should worry about documenting my decisions because they're all in my head and there's no way they can understand them if I don't, because they'll just keep asking me. So let me put the decisions down. So a lot of other things just arrive as a side effect.
Okay. So just considering maybe the most impactful and take it step by step, right?
Of course, that's always the way to do organizational change.
Thank you.
I've got one as well, but before the question, let me please introduce Victor. We've got Victor, our next speaker here. Hi, Victor. Can you hear us? Can you see us? You around?
Hey, Victor.
Hi.
Hi,
Hello.
Victor.
Nice ideas.
Victor. So that's what we sometimes do during the breaks. We connect people, great professionals doing things together. Sounds really good to me.
Sharing ideas.
Yeah. So now my final question would be, so in your book, you're discussing quite a lot using this metaphor, shifting to the left. Is it like a tiny dance or how would you?
Well, shifting to the left, I think, is just, you've got to be careful with shifting to the left. It's really interesting, actually. I've got a very quick anecdote about that. When we wrote the book, Simon Brown was one of the many people, I've known Simon for years, and I really admire his stuff. And so I asked him a lot to take an early look at the manuscript. And he said, I'm a bit worried about this shifting left bit, because if people take that too literally, because you keep talking about it in every chapter. We went, yeah, we do. Yeah, we do. He said, well, I'm a bit worried because if people just shift left, they'll just end up with all the architecture at the front. And you're trying to say the opposite. I thought, oh, never thought of that. That's a good point. Because you've got to bear in mind where shift left came from. Shift left came from people like Ops and me and people like Nick Wazanski who observed people trying to do all the security, all the performance, all the scalability right at the end. In fact, they almost handed a system to the infrastructure guys and said, if you could just make that secure, performant, and scalable, that'd be great. And infrastructure kind of went, well, it's a bit late. So that was the idea. Shift it left so that the system is at least securable before it gets anywhere near production. You don't put it in late. You've got to be slightly careful that you don't overdo the metaphor. It's really the metaphor should be distribute evenly. So you're doing security right through the life cycle. You do performance right through the life cycle. You do scalability right through the life cycle. You don't want to stick it all in one place.
Yeah, absolutely. Truly insightful. I mean, yeah, we want more, Eoin. So,
well, I love CodeCamp, so always happy to come and chat to CodeCamp.